Hello everybody, in this video we're going to continue our conversation from a previous video about talking about quadratic transformation. Now in this previous video we talked about what the quadratic parent function looks like. So I'm going to show you real quick. And we're going to constantly use this graph right here with these points to identify the transformations that are taking place. I also want to remind you that a lot of our transformations are going to look like this, where we have a quadratic vertex form versus the standard form equation that we're used to. We're going to look at what A does to the graph, what H does to the graph, and what K does to the graph individually. So I'm going to go ahead and look at the back side of this page. And we're going to talk about the reflections across the x-axis. So one of the things that I do want to point out before we move on, I do want to remind you, in order for this to work, please make sure you pause the video and create these graphs. If you already have these graphs, then this video is going to be a whole lot more productive because we're going to be able to focus on the conversations instead of worrying about creating those graphs. So pause the video if you need to create these graphs and then jump right back in. So here is our quadratic vertex form. Take a moment to write this on the top, and then I want you to make note that we're going to be looking at the A specifically. So a reflection across the x-axis is a change in direction. So if you originally have a graph that opens up, then once that graph opens down, that is a reflection across the x-axis. And so when we look at our graphs, we're going to find our original function, and then we're going to see what the new function is doing. And if it did change in direction, then that automatically tells us it's a reflection across the x-axis. Now when we're comparing it to the parent function, it is going to be a reflection when we go from a positive to a negative A value. So your A value in the front, just the sign, not the number, the sign is what causes a reflection. So let's go ahead and take a moment. You should already have these graphs on here. If you don't, like I said, pause. So this is our parent function because it is f of x is equal to x to the second power. We know A is equal to 1 because there's an understood 1 here. And if you look at the second function, which is g of x, the only thing that's different here, they both have x squared, but it's that this is a negative 1. It went from a positive to a negative. So we can clearly see that there's a change in direction, and therefore we can write that there is a reflection. So that's what I'm going to do down here. Once we identify that the A's go from a positive to a negative, then we get to say reflection. And since we're only going to talk about reflections across the x-axis, then we don't need to do anything except for write reflection. Okay? And then so if we look at the second set of graphs here, notice that the original this time was not the parent function. It is a function of negative 2x squared. The new function, the g of x, the one we're going to compare to f of x, is a positive 2x squared. So the A value up here is a negative 2. And the A value of g of x is a positive 2. So we are going from a negative to a positive. So let's look at the graph. So you can see that the first original graph is going to be this negative 2. So it is opening downward. Our new function is going to open upward. So if we're comparing the g of x to the f of x, we can say that there has been a reflection because it's been reflected across the x-axis. So we're going to say there is a reflection because there's been a change in direction, because there's been a change in signs from a positive to a negative, and also a negative to a positive. All right, let's look at our third example here. And so our original function is a 1/2 x squared, where A is equal to the 1/2. Notice that this graph is opened upward. And if you look at your g of x, we're keeping the same 1/2 x squared, but the 1/2 goes from being positive to being negative. So when we're comparing, you can see that the only change that has occurred is that it is flipped across the x-axis. So we get to say, once again, a reflection. Like that. So just to reiterate a couple of things, remember that the reflection can be seen in the a value of our equation. It is a change in direction. So going from up to down, from down to up, and it can be reflected as a positive to negative a value or a negative to positive a value. And don't look at positive, it is misspelt, but remember, numbers are my thing. So from here, that's all I wanted to tell you about the reflection across the x-axis. All right, I hope that these examples have helped. I hope that writing all these things have also helped you be able to answer those questions on the practice, especially when it's asking about reflections. So I'm going to pause right here, and then we will talk about vertical stretches and compressions in the next video. Okay, I'll see you there.